F equals ma in those coordinates. Okay, so let me refresh you on NT coordinates first. Okay, so the particle in this case is moving along a curve, and we can get the length of the curve by the parameter s. So if you draw a free body diagram for the particle, this is the curve. We can draw, we can write the normal and tangential components. So tangential is tangent to the curve, and normal is clearly 90 degrees to that. So this is 90 degrees. So in this case, what you'll do is you'll try to write forces, all the external forces in the NT coordinate frame. So maybe I should write it this way. This is U N U T. And I'm going to show the forces here. So force along T, force along N. So if you have gravity, friction, whatever you have, you got to resolve it along the tangential and normal coordinates, not along I and J. So once you do that, and there's another point which is, let's call this theta, okay? And I'll show you how to find theta. It will be important later on. So the equations of motion are the net force in the tangential direction is mass times acceleration in the tangential direction, and the acceleration in the tangential direction is, if you go back to chapter 12, we saw it's mv dot. The net external force in the normal direction is mass times acceleration in the normal direction, and if you go back again chapter 12, then we wrote down that as v square divided by rho, right? So you write F equals ma in NT coordinates. That's the new thing in this chapter, in this particular section. We also know how to find rho, which is the radius of curvature, which changes as the particle moves along the curve. If it's moving in a circle, rho is r, but otherwise rho is not constant. So we can write that as dy dx square, the whole thing raised to 3 divided by 2, divided the mod of d square y dx square, right? So let's assume that you can write the equation of this curve as y equals f of x. Y equals f of x. So once you know y equals f of x, you can find rho. The other thing which will be important is, how do you find the angle made by the tangential component with the arc length? So that is theta, and you can find theta using this formula. Right? Dy by dx is the slope, and that gives you the tangent of the angle between the ut and the arc length. Okay, so the steps for solving problems are exactly the same. That is, you draw the free body diagram. Okay, except that now forces are shown in the NT frame. You write F equals ma, but ma, the a is in the NT frame, and then a few auxiliary things which help you to find the acceleration. Okay, so it's the same procedure except that you change the coordinate frame. Okay, so let's apply this on a few problems. Okay, so the pendulum bob B has a mass of m and is released from rest, so it starts with a velocity of 0 or angular velocity of 0. Determine, and of course this theta is 0. Determine the tensions in the string BC, the tension in the string immediately after the bob is released, so in that position when theta is 0, and also when the tension T is at an angle theta. So first of all, since you're asked to find a force, this is a problem involving kinetics and not kinematics, which means that you've got to draw a free body diagram. Now the question is, would you use rectangular coordinates or anti-coordinates? This thing is moving along an arc, the pendulum, so anti-coordinates is appropriate. Actually, r theta coordinates, which is something which you're going to do next class on Friday, is also appropriate for this problem. Both those coordinate frames will work, but let's solve with this using the anti-coordinates. So we'll draw the free body diagram for B. Now one thing to remember is, even though the question asks you to find the tension when the angle theta is 0, I would recommend drawing a free body diagram when the bob is at a generic angle theta. That's because once you do that free body diagram, you can easily replace theta with 0 and get the answer for the first part. Okay? Do not draw it for that position. You can draw it, but you have to redraw it for angle theta equals not 0, because one of the questions asks you for that. So let's draw the free body diagram of the bob, the generic angle theta. So T is going to be the tension, and that tension is going to be at an angle of theta with respect to the horizontal, like this. Okay, now the gravity is not given here, but in the exam we'll give you gravity. We'll show you the direction of gravity, but gravity points downwards, so there's going to be mg acting downwards. And I think that's about it. Those are the two forces on the bob, right? So let's use anti-coordinates. I'm going to draw the anti-coordinates here to aid me in writing the equations of motion. Ut is along the tangential direction. Un is going to be actually un turns out to be in t direction. So this angle is also theta. Okay, so you're all set to write the equations of motion. So let's do a force equilibrium in the, let's say in the n direction. So Fn is mass times velocity in the normal direction. The velocity in the normal direction is v squared divided by rho, but rho in this case is just the radius of the arc or circle. In this case, the radius is the length of the string which connects the bob. So you do not have to use the complicated formula involving rho, because r is constant. It's given to you. Okay, so Fn, you can see that the tension is along the normal direction. So that's going to be positive t because it's pointing in the direction of un. And we're going to resolve mg along un. So that is going to be mg sine or cosine. What's the component of mg in the direction of un? Mg sine theta or cosine theta? Sine theta, right? Because this is also theta, so it's going to be mg. And I got to put a negative sign because it's in the direction opposite to un, so negative. Okay, let's try to do the force equilibrium in the t direction. So Ft is mass times velocity dot. Okay, since the tension x in the un direction, there's no component of t in the t direction or ut direction. So only component in the t direction is due to mg. So mg cosine theta, and you can see that the mg cosine theta points along ut, so it's positive, equals mass times v dot. Okay, let's try to find t at okay, so what we'll do is put theta equals 0. The velocity is actually r times theta dot, right? How did I get that? Well, you learned previously in the kinematics that when you have a rod like this, the velocity is always tangential, and it's simply r times theta, right? The magnitude, theta dot, sorry. But theta dot is 0 initially, so this is equal to 0 as theta dot equals 0. So if you put these things in, put in 1, let's call this 1, let's call this 2, put in 1 gives us t minus mg sine of 0 is 0 equals the velocity is 0, so mp m0 squared divided by r. So what you get is the tension is 0. Right? So next let's try to find the t at generic theta. Okay. So in order to find the tension at a generic theta, see that this is the expression for the tension, right? However, the tension should be expressed only in mg and theta. We're not allowed to solve in terms of v. So we got to solve for v, put it in here, and then write t as a function of theta only. So the way we can solve for velocity is use this equation. I'll use this equation, integrate that, get the velocity, put it in over here, and find the tension. So let's work with the second equation. So v dot is, so from to is g cosine theta, right? But v dot, okay, v dot is what? Is the acceleration. So v dot is dv dt, right? Now if I use dv dt and try to put it here on the expression here, I cannot quite integrate dt. I cannot do g cosine theta dt because cos theta is a function of time. I cannot integrate cos theta with respect to time, so that will not work. Okay. The other option is to use this formula v dv ds. Right, remember there are two ways to write v dot. It's v dv dt, other expression is v dv ds. This is something which we did way back in probably the first day of class, where we talked about, it was 12.1 or something like that, where we wrote v dot as v dv ds. Okay, if I take this and shove this in here, what will happen is this ds will go here, and I still will be stuck with integrating cos theta ds. I cannot integrate that because there's theta and there's ds. So is there a way I can write ds as a function of theta? Actually, there is a way. What is s? S is the arc length. It's this. What's the arc length of a circle? What's this? That's the arc length. Just put it there. This is the arc length. Do you know expression for the arc length for a circle? Well, that's for the whole circle. What's it for that? It's r times theta, right? For example, if you sweep 2 pi, then what you get is the circumference. It's 2 pi r. That makes sense. So it's r theta. So s equals r theta. So ds equals. So I need to take the derivative of r and theta. So I get ds. Well, I can do ds d theta. That's simply r, which means that ds is r d theta. So I can use this in this expression here to write v dot is v dv ds, which is v dv r d theta. So this is v divided by r dv d theta. That is 3 and 4. So what I'm going to do is I'm going to put 4 in 3 and then integrate. So that gives me v divided by r dv d theta is g cosine theta. So v dv is g times r cosine theta d theta. So when I carry out this integration, right, I need to go from 0 to v, and theta goes from 0 to some theta, which is I got to find that. Well, I need to write in terms of theta. So the left side is v squared divided by 2, v and 0 upper and lower limits. Gr is constant, so then I have the integral of cosine theta is negative sine theta, theta 0. So gr minus sine theta minus 0. Sine of 0 is 0. So v squared divided by 2 is minus gr sine theta. Is that right? Is the integral of cosine theta negative sine theta? No, it is right. It's positive. Okay, that's right, looks right. Otherwise I would have got a negative velocity, right? I mean square root of a negative quantity, which doesn't make sense. So v square is 2gr sine theta. So now I can take, I'll call this 5, and I've already found out expression for t. So I'm going to replace this v with what I found there. So put 5 in 1, I get t minus mg cosine mg sine theta is m divided by r times v square, which is 2gr sine theta. So the tension is 3mg sine theta. Okay, any questions? So it's very straightforward, as you see. You just have to know how to which coordinate frame to use, and then it's a matter of using the right equation, the right coordinate frame. Okay, any questions about this? Uses this notation, which is I thought was very confusing. The m signifies megagram, right? So it's 0.8 times 1000. Is that right? Yeah, the GB is good. So it's 0.8 times 10 raised to 6 grams. Okay, what's that in kilograms? 800 kilograms. So it's 800 kilograms, which is such an easy way to state it, but they said it as megagrams anyway. The zero point 0.8 mg car travels over the hill having the shape of a parabola. When the car is at point A, here, it is traveling at 9 meters per second. Let's write that down. V equals 9 meters per second. And increasing its speeds, which is V dot is 3 meters per second square. Determine both the resultant normal force, okay, and the resultant frictional force that all the wheels of the car exert on the road. Okay, so first of all, you're told to find forces, which means you've got to use kinetics, Newton's laws. The second hint here on what coordinate frame to use is that you're given y equals a function of x, which means that the most appropriate frame in this case is going to be the NT frame, not rectangular or polar. So let's draw the free body diagram. By the way, I'm not showing the ground there. Well, let me just draw a dotted line. I don't want to show the ground because that's not a free body diagram. But I want to show the curve so that I can draw N and T. Okay, so I'm going to draw the NT frame. Okay, UN always points towards the center of the instantaneous circle. UT is along the direction which the car is moving. Now to show the forces, so there's a force in the normal direction, which by the way is an unknown which is asked, and there's a force in the tangential direction. This angle is going to be theta. And finally, there's gravity. Okay, turns out that this angle is also theta. So next we write the equations of motion. Fn is mass times acceleration in the normal direction, which is mv squared divided by rho. So let's try to write all the forces in the normal direction. So Fn is clearly in the n direction, but Fn is in the negative n direction, right? Negative un direction, so it's negative Fn. Ft is clearly not going to be in the n direction, it's tangential. So we got to resolve mg. Mg cosine theta is along the un direction, so that's positive. Equals mv squared divided by rho. Okay, next Ft equals mv dot. Ft is, okay, note that I draw Ft in pointing along the left side because the friction force always opposes motion. The car is moving to the right. So Ft is going to be negative Ft equals mass times v dot. Am I missing something there? Is that right? I need to write mg, right? So mg sine theta is positive because that's going to be along ut. So mv dot. Okay. See. So I need to find theta here. It's an unknown. And I need to find rho. So let's find those. So rho is 1 plus dy dx square, the whole thing raised to 3 by 2, d square y dx square, and tan theta is dy dx. Okay, so This is equation for y. So dy dx equals 20 times minus 2x divided by 6,400, and d square by dx square equals 20 times minus 2 divided by 6,400. So I need to evaluate this at x equals what? I need to find the forces at A. At A, x is what? What's x at A? It's 80, right? It's showing there. Sometimes what they do is, one question might be, you might be given a y and not an x. You can use that equation to find x if you're given y. So that comes out to be half, negative half, and the second one comes out to be negative 1 divided by 160. Okay, so rho at x equals 80, you're going to sub the values for dy by dx and d square by dx square. Comes out to be 223.52 meters, and tan theta comes out to be negative 0.5, which means that theta is negative 26.57 degrees. Okay, so one, call this 1, this is 2, this is 3 and 4. Okay, at this point, do we know V? We do know V. V is, we wrote it down here. V is 9 and V dot is 3. So V is 9, V dot is 3. So we pretty much know everything here. We know mg, we know cosine theta, sine theta, found it out, we know rho. So we can sub in those values. Put 3, 4, V dot, mg in 1 and 2 to get Fn comes out to be 1.11 times 10 raised to 3 newtons, and Ft equals 6.73 times 10 raised to 3 newtons. Okay, pretty straightforward once you identify A, what coordinate frame, and draw the free body diagram. Yeah. Sure.
Are the two that you drew, like the one with the FT and the one with the MT, are the same?
One sec. Yeah, that's the same thing. So what you got to remember is that the angle made by the tangent with the arc is the same as the angle made by the vertical with Fn. Because it's actually, if you think it's confusing, let me just convince you that's true. So this is Ft, this is Fn, this is mg. So be sure that this is theta, right? What's this angle? Well, this is 90 degrees. So this has to be theta, right? Because this is 90 minus theta. Okay, last question. The 8 kg sack slides down the smooth ramp. If it has speed of, so smooth ramp is key. If it has speed of 1.5 meters per second, when y equals 0.2, so y equals 0.2, its speed is 1.5 meters per second. Determine the normal reaction force the ramp exerts on the sac and the rate of increase in the speed. So you asked to find V dot, and you're going to find the normal force. Okay, so actually this is a hint, right, that this is an anti-coordinate problem because you're told to find the rate of change of speed. Okay, again you're told to find the normal force, so it's a kinetics problem, it's a F equals ma problem. So let's start with the free body diagram. Sac. Show the coordinate frame. UN is always pointing towards the center of the instantaneous circle. UT is in the tangential direction. We call that N. What else is MG? This again is going to be theta, just like the previous example. This is theta. Is that it? I think that's about it. So since this is a smooth ramp, it's given here. There's no friction, so you don't have to draw friction force there. Okay, so we have to just write the equations of motion now. So net force in the normal direction is what? It's N. That's positive because it's pointing in the UN direction. And then there's mg cosine theta with a negative sign because when you resolve mg, it's along the negative UN direction. So that equals mv squared divided by rho. I got to find rho. Ft is the net force in the tangential direction. Okay. The only force in the tangential direction is due to mg sine of theta, and that points in the ut direction, so it's positive, equals mv dot. Okay, so what's unknown here? Well, this is what I'm asked to find. I'm given the v. I do not know rho. I do not know theta. I know g. I believe I know m. Yeah, I know m. I have to find v dot. Okay, so if I can find rho and theta, we can solve for n and v dot using those two equations. So I'm going to show you how to find rho and theta. So rho is 1 plus dy dx square 3 by 2 d square y dx square, and tan theta is, as we know, is dy dx. So as long as I can find dy by dx and d square y by dx, I should get rho and theta. So let's do that. So dy dx. So what's the equation of the curve? It's y equals 0.2 e raised to x. So dy by dx is going to be 0.2 times the derivative of e raised to x. E raised to x is e raised to x, and then d square y dx square is going to be 0.2 times. Well, it's the same thing. Okay, so in order to find the value for dy by dx, I need to know what x is, right? But I'm not given x. I don't know x, but I do know y. So I have to find x. X equals what? Well, you put 0.2 equals 0.2 e raised to x. So 1 equals e raised to x. So x equals what? Is 0. Okay, this comes from here. Okay, I'm almost done. I'll let you go. So now we know dy by dx, we know d square y by dx. So I can find rho. Rho comes out to be 5.3, and tan theta comes out to be 11.3 degrees. So this is using dy dx and d squared by dx squared. Okay, so given that, so now we know, so we know this, we know this, and we know this. So we can solve for n and v dot. So n is 80.4 newtons and v dot is 1.92 meters per second square. So let me call this 1, 2 from 1 and 2. Okay, so I'll see you on Friday.